Hello and good day to Dr. Edmund. My name is HARITH HAIFFIE bin HAIRANI. I am the leader of the group 19, and this is our members of the group, which consists of me, HARITH HAIFFIE, MOHAMMAD FAUZAN, MOHAMMAD SYUKRI, and also IYZMAN Daniel. And all of us are from HC00, which is software engineering. Welcome to AR Drag Racing, where players can make their own car materials based on the surrounding environment that is captured by scanning the surrounding area. With just only using Unity, Vuforia, and Sketchfab, my team and I had successfully built a fully functional AR drag racing game. I present to you the demonstration video for our game.
Hello everyone, so for my part I will be explaining about the menu navigation for our game. First of all, I would like to explain about menu navigation is an important asset in every game and it's a must-have as it creates an intuitive and responsive menu system for smooth user navigation. So as for our game, we have created three menus which consist of buttons where each of their response are respective to their own functions. Those buttons are the play button, the option button, and the quit button. These elements that made up the menu navigation is implemented using objects and raw images to make them interactive and visually clear for users to navigate through the game. So for the main menu navigation, first of all, the play button transition is implemented using the scene manager load scene function. Each of the scene in a game has their own built index scene. Then this function will take the index as an argument, which then enables users to transition to the game scene or back to the main menu instantly as they press the play button. Next is the option button, where in the option we will have one volume slider and one back button. For the volume slider, it is achieved through the UI slider element component in Unity. Then controls the audio volume as the slider value ranges from 0.0, which is mute, and 1.1 to indicate a full volume. This will be interacted through the user's input. Next is the back button. As users enter the game, they will be also given a specific button to go back to the main menu. This back button is also implemented in the game scene, which functions as the same way as the play button, but in this case, it goes back to the main menu scene. Last but not least, the quit game button, which quits the game once the users have done with their game. That is all from me. Thank you.
Okay, for the AR car material scanning scene, I'll be explaining the capture drawing.cs script, which is an essential part of our AR drag racing project. The script name is capture drawing because initially we wanted users to capture the hand-drawn drawing of a car and bring it to life. But we scrapped that idea and turned it into something new. This script allows users to capture their surrounding environment apply it as a texture, and generate a 3D model in real time. So yeah, the capture drawing.cs script is responsible for capturing a user's environment perspective, applying it as a texture, and displaying it on a 3D car model in real time. First, when the user presses the capture button, the capture photo function triggers text screenshot, which waits until the frame is fully rendered, and then captures the AR camera's view. The captured image is stored as a texture and displayed in a UI preview, allowing users to see their captured image before applying it to the car. Next, generate car function takes this captured texture and applies it to the 3D car model. It checks if the required texture, material, and car model exists. If everything is set up correctly, it updates the car's material and assigns the new texture. This process allows players to race with their custom designed cars. In summary, this script plays a crucial role in the AR drag racing project because it allows players to transform their surrounding environments into interactive 3D models, enhancing creativity and engagement. The AR car preview feature uses Vuforia to display the customized 3D car on top of a target image, which we imported from our personal Vuforia account. When the AR camera detects the target image, the car model with the applied custom texture appears on top of it, giving users a clear preview of their designed vehicle. To make the presentation more engaging, I also added a script that makes the car spin slowly, allowing users to view it from all angles. This spinning effect adds an immersive gameplay experience and makes the preview more dynamic and interactive.
Hello, I'm SYUKRI. I will be presenting the map design of our AR drag racing game. The map is designed to create an immersive and exciting racing environment while maintaining a simple and user-friendly layout. The background consists of a detailed landscape featuring trees, street lights, and a nighttime setting to enhance the racing atmosphere. One of the 2D objects added is a tree, in which was imported from Sketchfab to give the environment a more natural and realistic look. These elements help bring the race track to life and make the game visually engaging for players. In the race, there are two cars in which are the AI opponent and the player's car. The AI opponent provides competition, making the game more challenging and fun. The player's car is fully interactive, allowing users to control speed and movement during the race. To control the car, the game includes two main pedals, in which are the gas pedal and the brake pedal. The gas pedal is used to accelerate, while the brake pedal slows down or stops the car. These controls are placed on the bottom right of the screen for easy access, ensuring smooth gameplay. Additionally, there are obstacles like bananas placed in the middle of the road, making the race more challenging and exciting. Players must carefully navigate around these obstacles to avoid slowing down and losing the race. With these design elements, the map provides a visually appealing and interactive racing experience. The combination of AR technology, real-world scanning, and engaging track elements makes the game both fun and challenging for players. That is all from my part.
The script of the game is actually quite simple. Perhaps we only need to focus on two things, which is player script to control our car and enemy script that will act as our opponent that move autonomously. On the left side, for player script, there's only three things to understand. The first one is the trigger function for our gas pedal. This is when the pedal is being pressed, the speed of our car will be increased. The second one is the trigger function for our brake. It is very similar to the gas pedal, where if we press the brake, it will decrease the speed of the car. Last one is a special function when our car is colliding with a banana, and when it's collide, it will also decrease the speed of the car. Now, to the right side, for enemy script, the logic is very straightforward. We want to create an opponent that has no pattern and unpredictable. So we decide to randomize the speed of the car all the time. So there is a time where the car will be move faster than normal, slower than normal, or move normally, or even doesn't move at all at the time. In that way, it makes the game more complex and not the same all the time.
Okay, for the scene management, I use two methods. The first method is a simple on-click button system where each button calls a function to load a specific scene, such as the car material scanning, main menu, racing scene, and AR car review scenes. The second method is an automatic scene transition in the racing segment, where a finish trigger script is attached to a capsule at the finish line. When a car crosses it, the game checks if it's the player or enemy and loads the corresponding scene, which is win game over if the player finishes first and game over if the enemy wins. Our team faced several challenges while developing this project. Since most of us were using Unity for the first time, it was difficult to learn at the beginning, but we improved by troubleshooting errors along the way. Our original idea was to scan a hand-drawn car and convert it into 3D, but this required complex tools like OpenCV and Blender, making it too difficult. So we changed our approach to scanning the environment and using it as the car's texture and material instead. We also struggled with tags and collisions, especially when setting up interactions like detecting the finish line and handling objects like bananas in the racing segment. That is all from us from Group 19. We learned a lot in this subject, especially about VR, AR, and Unity, and it's our first time in making a game and exploring the new game mechanics, and this is good for our own future. So yeah, thank you very much. Thank you, Dr. Edmund, and thank you.